Common characteristics of soils with different textures. High sand content. Can cultivate when moist or wet. Somewhat dusty when dry. Doesn't form clods. Quick to warm up in the spring. Low levels of organic matter. That organic matter breaks down quickly, especially in warm, humid areas. It's easy to correct soil acidity or alkalinity, but the corrections don't last long. Low to moderate risk of water erosion. Feels gritty between the fingers. With a high silt content, it's harder to cultivate when moist or wet, often very dusty when dry. It rarely forms clods, being somewhat slow to warm up in the spring. It's moderate to high levels of organic matter. That organic matter breaks down somewhat quickly. Hard to correct the soil acidity or alkalinity in soils with high silt content. It's high risk of erosion in windy areas. High risk of erosion by water. It feels silky between the fingers, and any grittiness is very fine. With a high clay content, do not cultivate when wet or sticky. There's a high risk of compaction. It's very hard or cement-like when dry. Slow to warm up in the spring. Has high to moderate levels of organic matter, and that organic matter breaks down slowly. It's very hard to correct soil acidity or alkalinity in high clay content soil, but once corrected, the effects last. It's low risk of erosion in windy areas, low risk of water erosion if the structure is good, high risk of water erosion if the structure is poor. It feels smooth between the fingers and sticky when wet. Managing texture. There's a simple fix for soils with less than ideal textures. Add organic matter. Lots of organic matter makes soils of any texture behave more like ideal loam. While adding pure clay to sand will improve its texture. In practice, it's hard to do. It's easy to buy coarse sand to add to clay, but it's very hard to add enough to improve drainage. Organic matter is much easier to add and more effective. Abundant amounts of organic matter increase the ability of sandy soils to stay moist and retain nutrients. Magically, they also improve the aeration and drainage of clay soils. Chapters 4 and 5 explain many ways to increase your soil's organic matter. Extreme textures may need more than organic matter. Clay soils must be handled carefully and often benefit from double digging. Building a raised bed may be required where drainage problems are severe. Careful plant choice will help you in very sandy soils or any other extreme soil. Chapter 7 explains techniques and plants for soils with problem textures. How soil texture affects soil properties. When the texture is loam, the aeration, which is porosity, and the ease of water infiltration is medium. The ability to hold nutrients and the water holding capacity of the loamy soil is also medium. The ease of working is medium. In a clay soil, the aeration and ease of water infiltration is poor, while the ability to hold nutrients is excellent. The water holding capacity is good, but the ease of working a clay soil is poor. Silty soil is medium porosity and ease of water infiltration, and a medium ability to hold nutrients, a medium water holding capacity, and a medium ease of working. Sand has excellent aeration and porosity and good ease of water infiltration, but a very poor ability to hold nutrients and water holding capacity. The ease of working is very good with sandy soils. Testing soil texture. Classify your soil's texture by measuring relative amounts of sand, silt, and clay with the following simple test. Since your garden varies slightly from spot to spot, your sample should combine soil from several spots to give you an average. Avoid extreme areas, such as unusually wet or dry spots. Try testing these areas separately to see if soil texture explains why they're different. For this test, you need a bucket, a trowel, a quart jar with a lid, water, dishwasher detergent, a clock or a watch, a grease pencil, a ruler, and a calculator is optional. You start by digging 6-inch hole in 6 different spots throughout your garden. Cut a long slice of soil from the side of each hole. Put all the slices in your bucket and stir well. You should have at least 2 cups or so of mixed soil. Place 1 cup of mixed soil into the quart jar. Remove any large pebbles, sticks, or plant parts. Fill the jar nearly to the top with water. Add about ½ teaspoon of dishwasher detergent. Cover and shake the jar vigorously. If any lumps remain, shake again. Set the jar of muddy water where it won't be jostled for at least 24 hours. After half an hour to an hour, you should start to see a distinct layer settled out at the bottom. This is the sand layer. With a grease pencil, draw a line on the jar to mark the top of this layer. Wait another hour. You should see a second layer. If not, check back in another hour or so. This is the silt layer. Mark the top of this layer with the grease pencil. After 24 hours, or when the soil is clear, mark the top of the next clay layer. Don't jostle the jar, as clay is very easy to stir up. A quick glance will give you the relative proportions of sand, silt, and clay. To calculate your percentages, you'll measure the height of each layer, divide the total height into the height of one layer, and multiply your result by 100. So assuming you have 2 inches of soil in your jar, with a 1/4 inch of sand layer, a 1/2 inch silt layer, and a 1 1/4 inch clay layer, this would work out to 0.25 divided by 2 equals 0.125 times 10, or about 13% sand. 0.05 divided by 2 equals 0.25 times 100, or about 25% silt. 1.25 divided by 2 equals 0.625 times 100, is about 63% clay. You can check your percentages against these here to figure out your soil's texture. Clay loam is common. If your soil has a lot of either silt or sand, call it silty clay loam or sandy clay loam. Sandy loam is also common. If you have 70 to 85% sand, call your soil loamy sand. Classifying your results. 55% clay equals a clay soil. 25 to 55% clay, a clay loam. 85% sand is a sandy soil. 50 to 70% sand, sandy loam. 85% silt is a silty soil, with 50 to 80% silt being called silty loam. The structure of soil. Structure describes how soil hangs together, how much soil particles clump into crumbs or clods. Loose crumbs or clods ensure ample pore space no matter what your soil texture. As a result, good structure can compensate for less than ideal texture. Soil with good structure absorbs more rainfall more quickly, and excess water drains away quickly. Roots and soil organisms push through more easily, and gardeners dig with ease. Good structure makes a good garden. Sidebar, hint for success. How to promote ideal soil structure. Keep levels of organic matter high. Add compost, manure, or plant residues regularly, or grow green manure crops. Encourage abundant, healthy soil organisms by adding organic matter. Cultivate soil only when moist. Avoid walking on or driving machines over wet soil. Make sure soil contains a good balance of calcium and magnesium, but avoid over-liming. Cover bare soil. Mulch areas that aren't covered by plant leaves to minimize pounding from heavy rains. Keep soil in use as much as possible. Plant green manure or a cover crop in an area if it will be bare for a couple of months. Minimize rototilling and other forms of cultivation, as these break up desirable soil crumbs and channels. Managing structure. As with texture, the easiest way to improve soil structure is by adding organic matter. Once you've achieved good structure, it's impossible to maintain it without maintaining good humus levels. Organic matter, plus a few months' time, may be all you need to improve powdery soil or a few large clods. Compacted structure, soil that's crusted on the surface or forms a dense layer, hard pan, below the surface, is harder on plants and takes more effort to fix. Rainwater and roots can't enter easily, and it can be hard to dig. Adding organic matter isn't enough. You'll need to try double digging or loosening with a broad fork. When to work your soil. A simple squeeze can tell you if your soil is ready for digging or cultivating. Grab a handful of soil and squeeze it. When you open your hand, do you see just loose powder? Your soil is too dry. If you can't wait for rain, run a sprinkler long enough to moisten the top few inches and wait several hours, or ideally overnight, before digging. Does water run out when you squeeze, or do you see a solid sticky lump in your hand? Your soil's too wet. Wait a day or two and test another handful before digging. Do you see a mostly solid lump that breaks easily apart when you poke gently at it? Dig away. Your soil is slightly moist and just right for cultivating. Examining soil structure. The best way to learn about structure of your soil is to look at it. Start by digging a hole and comparing the soil on the sides with the loose soil removed from your hole. To test the stability of your soil structure, see if its crumbs hold up when you add water. First, you're going to dig a small hole about a foot deep. Can you see ½ or quarter-inch to ½ crumbs in the top few inches? Ideally, you'll see some crumbs even 12 inches down. The crust on the surface or a dense layer of hardpan partway down is a sign of poor structure. Does the soil removed from the hole contain lots of ½ crumbs? Do larger clods break apart easily? This is signs of good structure. Place a handful of soil crumbs into each of 2 glasses. Gently pour water into one of the glasses to cover the soil. If your soil has a good, stable structure, the crumbs will hold together even when wet, so the wet and dry samples should look similar. Pour water into the bare soil in the garden. Does it flatten all the crumbs into a fine, even layer? This effect, called puddling, is a sign that your structure needs improving.